Question for you. I'm going to apply squeeze theorem. So suppose I give you the following inequality. Does knowing that, check the question, inverse tangent xy divided by xy bounded by 1 minus x squared y squared divided by 3 now less than or equals to 1 tell you anything about the limit of inverse tangent xy over xy as x and y approach to the origin 0 and 0. So take a look at this. Here we have an inequality inverse tangent xy divided by xy is bounded between these two. 1 minus x squared y squared divided by 3 and 1. Well, you can derive these formulas using series from your elementary calculus. You can squeeze a function inverse tangent xy divided by xy between these two. And then knowing that you have this inequality help you to find the limit of inverse tangent xy divided by xy. So let's go back to elementary calculus. Recall that if function f is bounded between two functions like g and h, and suppose the limit of g and h both exist and they are equal to each other. For example, both of them are equal to L. So it means that this function locally is sandwiched between g and h as the limit of g and h are equal to each other around a, the limit of f of x must be equal to the same value. So limit of f of x as x approaches a must be L. We are extending the idea, generalizing the idea to a two-variable function. You're going to say that, hey, since I know the middle function is bounded between two other functions, let's just start taking the limit. The limit of 1 minus x squared y squared divided by 3 as x and y goes to 0 and 0. And the limit of your inverse tangent xy divided by xy as xy goes to 0 and 0, which is less than the limit of a constant value 1 as x and y approaches to 0 and 0. Well, the limit of 1 as a constant function is always 1. So on the right hand side, this guy is 1. On the left hand side, here you have x squared times y squared. It means that to find the limit, remember the very first step, it was substitution. It becomes 1 minus 0 divided by 3 or just 1. So the limit from left is also 1. So the squeeze theorem says, hey, since the limit from left is 1, the limit from right is 1, the limit of the middle function must be equal to 1. So limit of inverse tangent xy over xy as x and y goes to 0 and 0 must be 1.